One thing I just want to mention, as I've mentioned to my other classes today, okay? You have got to ask questions. Okay? If you are not understanding something, you have got to ask. Even if you don't know what to ask, just say, Miss Barlow, I'm not understanding this. Could you maybe go over it again? Could you say this in a different way? Okay? At some point, you have to take responsible for your learning too. Okay? I'm doing my part. I want to make sure you understand it. But if you're not telling me that you're not understanding it, then I'm assuming everything's fine and dandy when it's not. Okay, so I said this to all my other classes today, but you've got to take responsibility for your learning. Okay? I think that asking questions, asking for help, coming and getting tutoring is a sign of strength, not a sign of weakness. Okay? It shows that you care and that you want to understand it. Okay? So just keep that in mind moving forward, that if there's something that's not clicking or anything like that, and you want to understand it, then you need to ask questions. Okay? Does that make sense? All right. Now, let's go over this, and if you have questions, please raise your hand. All right, so for numbers 1 through 3, you need to state the missing information to show that the triangles are congruent. Okay? If you were out on Friday, I would highly, highly, highly recommend you watch this lesson, because you are going to be absolutely lost. Even if you were here on Friday, if you're still a little confused, maybe going and watching the lesson again is not a bad idea. Okay? It's there for all of you to watch. All right? So for 1 through 3, you need to state the missing information to show that the triangles are congruent. So remember for these problems, there's only one piece missing. Okay? One piece missing. So you need to, if there's more than one piece missing, one of those is your quote-unquote obvious. You just got to figure out what the obvious is and what the non-obvious is. So for number 1, I'm asked to show that these are congruent by side, angle, side. All right? Remember, for side, angle, side, the angle must be in the middle. It must be in between the two sides. Okay? I'm given that this side and this side are congruent to each other. Right? Which means that's all I was given. I'm missing 2 pieces, which means one of them has to be my obvious. Okay? And if you look right here, I've got vertical angles. I've got intersecting lines, opposite angles. So those angles are vertical, which means they're congruent. That's my quote-unquote obvious. So then you need to figure out the non-obvious, and that missing side needs to be in between the other angle on the side, which would be WB and XB. Okay? If you chose VW and ZX, then that angle is not in between the sides. Okay? So you can't choose that, otherwise it's not side, angle, side. Alright? For number 2, you want these to be side, 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 which means all 3 sides need to be congruent. Remember, any side of a triangle that's the same with both triangles is going to be congruent to itself. Okay, so QS is going to be congruent to itself, which means you only need one other side. You would need QR and QY. And then for number 3, you want this to be side, angle, side. Notice that JK is going to be with both triangles because that's the same side. So that means I need an angle. I need the angle in between the 2 sides. So that would be this angle right here, RKJ, and this angle right here, IJK. Okay, because the angle ends up being in between the sides. So, any questions on 1 through 3? Do we understand what I'm saying when I say in between the sides or in between the angles? Does that make sense? No? Okay. If I have a triangle, this angle is in between the sides. Okay? So, I liked how I had a student word it in first block, because I just couldn't figure out another way to say that. This angle is made up of those 2 sides, right? So, if that angle is not making up those 2 sides, and that angle somewhere else, that is not side, angle, side. Okay, so that angle has to make up those 2 sides. That's what it means for the angle to be in between the sides. Does that make a little more sense? Okay. All right, good. Okay. Also, with number 3, for number 3, you can't say that, for example, the angle you need is K. Okay, because K is that entire angle. I only need that little sliver for this triangle. Okay? Are there any questions at all on 1 through 3? All right, and then as always, if I'm just going too fast or something, just ask me to slow down. Okay? I don't mind that. All right, for 4 and 5, hopefully these weren't too terribly bad. You just needed to look at the name and be able to list all your corresponding parts. So for example, F is the first letter, That means it's going to be congruent to the first letter over here, which is P. G is the second letter, it's going to be congruent to the second letter, R, so on and so forth. Same thing with your sides. F and G are your first two letters, that's going to be congruent to the first two letters over here, P, R. F and H are your first and third letters, that's going to be congruent to the first and third over here, P, Q, so on and so forth. Okay, and then the exact same thing for number 5. So I'll give you just a second to look at those, check your answers. I have the floor open for questions if you need it. Alright, now let's talk about your proofs. Okay, so remember the first thing you need to do in a proof is list your givens. If you can't do anything else, you can list your givens. Okay, and I kind of slacked a little on that on here, so I apologize, but hopefully you listed your givens. Okay, I just kind of got a little lazy. Alright, so, and notice that with these proofs, there's lots of things that come up a lot. Okay, reflexive property, midpoint, bisector, vertical angles, those things come up over and over and over again. Okay, so if there's ever something that you can't find, look for those things that we've talked about, because as you've seen with the notes and the homework, they came up a lot. Okay, so for number 6, you're given that D is the midpoint of AB, which means D is cutting AB in half. So that means AD and BD are going to be congruent to each other. You're also given that AC and BC are congruent to each other, and then CD is congruent to itself, because that's reflexive property. Okay, if you need to, I've said this to my other classes today, if you need to, draw 2 separate angles and label them and see what's common that way. Okay, do whatever helps you. All right. So from there, you've got 3 sides. You can say that those triangles are congruent by side, side, side. All right. For 7, remind me what bisect means.
Cut in half.
Cut in half. Okay. So this is saying RS and PQ bisect each other, which means they are cutting each other in half. Okay? So that means RT and ST are congruent to each other. QT and PT are congruent to each other because they are getting cut in half. So that means the halves have to equal each other. Okay? Then I've got intersecting lines, opposite angles, those are vertical, those are equal to each other. Okay? So those are congruent. And then so I've got a side, an angle in between, and a side. So I can say that those are congruent by side, angle, side. Does that make a little more sense with that angle in between? Can we visualize that now? Okay, good. Okay, so those are congruent by side, angle, side. And then for number 8, unfortunately I can't scroll down. But remember, so notice that for 6 and 7, it says prove that the triangles are congruent. But for 8, it says prove that those sides are congruent. Okay, anytime it doesn't say prove the triangles are congruent, that means you got to use CP/CTC at some point. Corresponding parts of congruent triangles are congruent. So you have to prove that the triangles are congruent first, and then once you've done that, you can use CP/CTC. So you're given that QP and SP are congruent to each other, and then you're given that that angle is congruent. And then you can say PR is congruent to itself by reflexive property. So I've got a side, an angle, and a side. So I can say side, angle, side. And then now that I've said they're congruent, all the corresponding parts have to be congruent to each other as well. And you can see that QR and SR, they're in the exact same position in terms of the triangles. So you can go ahead and say that those are congruent by CP/CTC. Are there any questions on anything on that homework? Anything at all? Alright, we also need to do a better job of staying awake today. Okay, I know this is not the most fun thing in the world. It's pretty boring. Trust me, I get it. But we gotta stay awake because obviously if we fall asleep, then we're gonna be lost. Okay? So we need to stay awake and we need to actively ask questions if we're confused. Okay? You have to take ownership of your learning as well. Okay? Alright. Key will be on Schoology, so if for some reason you didn't turn in your homework, if you turn it in tomorrow, it's only 10% off. After that, the most you can have is half credit. Alright? So you may put that away and have out today's notes on your desk now. Everyone have a copy of today's notes. Alright, so today we are continuing on with our triangle congruence. So on Friday we talked about 2 of them. Today we're going to talk about the other 3. Okay? So, what's that face for? Okay. So, the first one we're going to talk about is angle, side, angle. Okay? So, angle, side, angle says if two angles of one triangle in the included side, okay, remember included means in between. So, notice that this side is in between the angles. Okay? So, if I have 2 angles and the side in between are congruent to 2 angles and the side in between in another triangle, then those 2 triangles are congruent by angle, side, angle. Okay, so the first thing we need to do is label the corresponding parts, just like we did on Friday. Okay, so which angle is congruent to angle M? S. Okay, remember 1 arc. So 1 arc, that means those are congruent to each other. All right, if I name this side MN, be careful. What's the other side called? ST. Good. ST. And then angle N is congruent to angle T. Okay? Because it has those 2 arcs. Alright? So I can say, if I name this first triangle MNL, how do I name the second triangle? STR. STR. Good. So MNL is congruent to STR by angle, side, angle. So notice that I started off with M, so I need to start off with the 1 arc over here, that's S, and then so on and so forth. Alright, the next one is called angle, angle, side. Okay, so if I have 2 angles and the side not in between the angles, and that's congruent to 2 sides and an angle, or 2 angles and a side not in between the angles on the other triangle, then I can say those triangles are congruent by angle, angle, side. Okay? So, once again, let's do this. What angle is congruent to angle U? X. What about angle V? Y. And then, side VW is congruent to what? YZ, there you go, YZ. Okay, so I can say, if I name this first triangle UVW, how would I name the second one? XYZ, good. So those triangles are congruent by angle, angle, side, because that side is not in between the angles. Alright, this last one is called hypotenuse leg. Alright? Yes. Yes, yes, absolutely.
I just want limit.
Do what?
I just want limit.
Give me an example.
Like, say you did you.
Okay, so I chose that however I wanted to. You just have to be consistent with the next one. So because I chose you to start off with here, I have to start off with X here. Okay, so how you name the first one is up to you. The second one, you just have to be consistent. Okay, good question. Good. Okay. Alright, the last one that we'll talk about is called hypotenuse leg. Okay, the biggest thing about hypotenuse leg, it must be a right triangle. Okay, hypotenuse leg does not work for any triangle. It's got to be a right triangle. Okay, and then remember, we talked about this a few weeks ago. If I have a right triangle, the hypotenuse is the side that's across from the right angle. Okay? So in case you need a reminder of what a hypotenuse is. And then the other sides are just your legs. Okay? So if the hypotenuse and one leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then I can say the triangles are congruent by hypotenuse leg. Okay? So once again, one more time, let's go through and list these. Side MN is congruent to QP, good. And side ML is congruent to, hold on, ML. Yeah, PR, there you go, PR. ML, I'm sorry. M as in milk. Alright, and for hypotenuse leg, all you need is that it's a right triangle, the hypotenuse, and the leg. So from here, if I say triangle MLN, what is it congruent to? PRQ, there you go. Okay, M, I started down here, look Roy, I started down here. That's in between the two sides. I need to start in between the two sides here, so that's P. Okay, so P, and then I started with the right angle, so my right angle's R. And then I ended up back up top, which is Q. Okay, the PRQ. Alright, also notice, okay, I'm going to let you figure it out, but notice that there is no, think about the abbreviations. There's no angle side side. Angle side side does not exist. So think about what that abbreviation stands for. Did we get it? Angle side side. Come on, Rita. There you go. There you go. Uh-huh. Okay, angle side side. That does not exist. Did we get that or no? Yes? Okay. Think about what that stands for. Angle side side. ASS. Good grief. Okay, that does not exist. Okay? So do things like angle, angle, angle. Okay, that does not exist either. Okay? What I will tell you, so on your Delta Math tonight, you may have some triangles that say that all three angles are congruent, and it'll say, you know, your answer is angle, angle, angle. But angle, angle, angle is not one of these five. So you can't prove that a triangle is congruent by angle, 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 or angle side, side. Okay? And they give you that as an option, but then you would say that you can't prove that they're congruent. Okay? So you can only use these five. So don't put ASS on your test. Alright. Anyways, I need to determine if these triangles are congruent by angle, angle, side, hypotenuse, leg, or none of the above. Alright, so this first one, what do we think? Angle, angle, side, hypotenuse, leg, or none?
Angle side.
What were we going to say, Julia? Angle, side, do we agree? Yes, no?
No.
Yes. Okay, it's angle, side. Alright, I've got two angles, and the side is not in between the angles. Okay, since the side is not in between the angles, that's what makes it angle, side. Okay, if it were angle, side, angle, then your side would have to be right here. Okay, but since that's not the case, it's angle, side. Alright, what's number 2? None, good, okay, it's none. Alright, I have what looks like for this first one to be angle, side, angle, but then for this second one it looks like I have angle, side. Alright, so it's got to be the same for both. Alright, so because it's not the same, I would say none. Do you need to step out?
No.
Okay. Alright, so it's got to be the same for both. Sit down now. Okay. Alright, so what does that make number 3?
Angle side.
No,
No, none. No.
Do you see why it's none? Okay, so 3 is also none, okay? Look at the first triangle. This first triangle is angle, side, angle. But the second triangle is angle, angle, side. Okay? They've got to be the same. So that's why for 3, it is also none. They've got to be the same. I can't have one that's angle, side, angle, and the other one be angle, angle, side. Gotta be the same. Alright, what's number 4? Hypotenuse leg, good, okay? This right here that I'm about to mark, you see that that's the same side for both triangles? Is that a leg or a hypotenuse? That's a leg, okay? That's a leg. Remember that your hypotenuse is across from the right angle. So this I just marked is a leg. Okay? And then my hypotenuses are congruent to each other. Okay, so that one is hypotenuse leg. Remember the hypotenuse is across from the right angle. Alright, and then lastly, what's number 5? Angle, side, angle. Good. Angle, the side in between, and then the angle. Alright, I want to stop there and ask you if there are any questions. Anything, any one of these you don't understand why the answer is what it is. Please don't be afraid to ask because there's a chance. I know every teacher says this, but it's true. There's a good chance someone else is just as confused as you are. I know everyone says that, but it's true. Alright, then let's keep going. Y'all try to stay awake, okay? I know this isn't that fun. No, I get it. Alright, for these next 4, determine what additional information is needed to show that the triangles are congruent. Okay, when you're doing these problems, determine the additional information. You're looking for one thing only. Okay, if it looks like there's more than one thing missing, one of them is your quote-unquote obvious. Okay, so there's only one thing that is really missing here. Alright, so let's talk about number 6. I want these triangles to be congruent by angle, side, angle. Notice that I only have one thing marked missing, which is an angle, which means I'm technically missing a side and an angle. But I'm only looking for one thing, so one of these angles or sides needs to be obvious. Okay, are you answering her? Oh, okay. What is obvious here? The side. Okay, what side? What's it called? Name it. TU. Okay, TU is the same for both triangles, right? So if you need to, redraw the triangles. Okay, if I redraw these triangles, they both have TU. Okay, so that side has got to be congruent to itself. Okay, so that's my quote-unquote obvious, which means I'm missing an angle. Okay, I need the angle that's going to be in between those sides. Name the angles. No, not quite. Okay, let's break apart the triangles. Okay, let's break these apart. T, U, V, and T, U, F. Okay. Did you see? Does that help a little? No? Okay. I want these to be congruent by angle, side, angle. So that means the side needs to be in between the angles. Okay, I have an angle and a side, which means I need another angle. And I need to place the angles so that the side is in between them. So you gotta use 3 letters for an angle. Alright, let's just focus on the 2 triangles first. Let's focus on this one. Just focusing on it, where do I need to put the angle? Just use one letter for now.
So 2T.
T. Do we see that? T. That angle, if I place it there, now the side's in between. Yes? So what is the name for that angle over here? No. Trinity, I heard you say it earlier. Say it. VTU. VTU. The vertex has to be in between. So that's one of them. Okay, now look over here. Where do I need to put my angle so that the side is in between? U. Right there. Right? Now the side is in between the angles. What's the name of that over on the big picture? TUM. There you go. TUM. Okay? Draw out the separate pictures if you need to. Okay, I'm sensing that y'all aren't understanding, but you're also not asking questions. And that's the thing that's annoying. Okay? That's what I'm talking about, taking ownership of your learning. Because if you're not asking questions, then you're just accepting the fact that you're not going to understand it. And that's not what I want you to do. Alright, let's look at number 7 then. I need these triangles to be congruent by angle, angle, side. I've got an angle and a side, which means I need another angle. The thing with angle, angle, side is you don't want the side to be in between the angles. Any ideas? Roy, what you think?
Sorry.
J and?
I mean, wait, no, I don't know.
J and T.
J and T, there we go, J and T. Okay? Notice that they're in the same position. And if I put my angles there, that side is not in between them. Okay? So J and T works. Alright, this one's actually a special case where both sets of triangles, or not both sets of triangles, both sets of angles would work. So you could say J and T, or you could say I and U. Because notice, no matter what pair you choose, whether it's I and H or H and J, the side is still not in between the angles. So you could say J and T or I and U. Either one of those would work. That's kind of a special case. Alright, number 8. I want these triangles to be congruent by angle, angle, side. Okay? Notice that the only marking I have is an angle, which means a side and another angle's missing. But remember, I'm only looking for one thing, so one of those has got to be obvious. Which one's your obvious? The side. Name the side. LK. Okay? LK is going to be congruent to itself. Alright, so I need another angle. And remember, you don't want the angle to be you don't want the side to end up in between the angles. So which two angles do you need? J and?
A and J.
Good, perfect. A and J. If I use A and J, notice I have an angle, and then a side that is not in between. Good. Alright, and then for number 9, I want these to be congruent by hypotenuse, leg. Okay? Notice I have no side markings listed. So I need two sides. I need a hypotenuse and a leg. Alright, one of these has got to be obvious. You are. Good. Okay, is that your hypotenuse or your leg?
Leg.
That's your leg. Okay, that's your leg, which means I need my hypotenuse. So which two sides are my hypotenuse? Good, good. Or be careful how you word that. RX. Yes, QP. Because you gotta start, if you start from the top here, you gotta start from the top here. So QP and RX. Good. So those are my hypotenuse. That's what I want to be congruent. Okay. Alright. Are there any questions on the front? I want you to actually take a second and look at it. Okay? Don't just flip to the back. Take a second and look at it. And if there's anything you're not understanding, I need to know now before we move on. Because now we're about to start doing proofs, and I know how much y'all love them. So, I need to make sure before we start that we're clear on everything on the front. So now's your chance to ask a question if you have one. Okay. All good? Alright. Look to the back then. Alright. Now let's work on our proofs. Okay? Number one, let's talk about it. Prove that these two triangles are congruent to each other. Okay? I'm given that PR is the angle bisector of angles QPS and QRS. Let's stop there. Alright? We haven't talked about what an angle bisector is, but I think we can use some context clues. Bisect, what does that mean? Cut in half. Okay? If it's an angle bisector, what is it doing to an angle? Cutting it in half. Right? Cutting these angles in half. Alright, so it is cutting angle QPS. QPS, it's cutting it in half. So that means the two halves have to be congruent to each other, right? Just like if it was a perpendicular bisector. It's cutting the line in half. Alright, it is also an angle bisector for QRS. So those halves have to be congruent to each other. Alright. What is the very first step in a proof? State your givens. State your givens. Okay? So my given is that PR is the angle bisector of QPS and QRS. And how do you know that? You were given that. Alright? That's my given. Alright, from here, I can say, let's see, where else can I go from here? Let's talk about these angles. Okay, if I name this one QPR, name the angle it's congruent to. SPR, good. Okay, SPR. And we can say they're congruent by definition of an angle bisector, because by the definition of an angle bisector, those are congruent to each other. Okay, so definition of angle bisector. Alright, I can say the same thing, so if I name this next angle as QRP, so this one right here, QRP, how do I name the angle congruent to it? SRP, okay? They're congruent to each other by the exact same reason as before, definition of angle bisector. Because the angle bisector QR is cutting that angle in half. So I've talked about my angles. So I have two angles. Now I need a side of some sort. PR. How is PR congruent? Reflexive property. Okay. Oh, you were after that. Okay. So reflexive property just means it's congruent to itself. So you see how PR is going to be the same for both triangles? That's just your reasoning for saying it's going to be the same. Okay. So PR is congruent to itself by reflexive property. Good. Alright, so does that make this angle side angle or angle angle side?
Angle, side, angle, side.
Not side angle side. I only got one side. Angle side angle. Okay, look at the picture. I've got an angle, a side in between, and another angle. Okay, so that would be angle angle side. So I can finally say that RPQ is congruent to RPS by angle side angle. Okay, before we move on, read over that one more time. Make sure it makes sense. If it doesn't, I need to know. Yes, Julia. Do what? Oh, that's just a box with a X in it, just saying I'm done with my proof. Yeah, that's just a notation for saying I've finished my proof. Other questions? Alright, then let's continue on. Number 2. Prove the triangles are congruent. Alright, and then also, label your picture as you go, okay? That's what it's there for. Do whatever you want with it. Alright, so I'm given that V and U, those angles are congruent to each other. And I am given that segment EF is perpendicular to segment VU. How's that helping me? EF is perpendicular to VU. Say it again. Perfect. Okay, so they intersect at a 90-degree angle. Very good. Perfect. Okay, go ahead and write out your givens. I can trust that at this point you can do that. Yes, ma'am. Thank you. Just watch the video. Alright, so V is congruent to U. And then EF is perpendicular. Remember, perpendicular is that upside down T. Okay, so I'm just going to use that. EF is perpendicular to VU because I was given that. Alright, so that's my givens.
When we're writing our givens, do we have to write them separately, or can we write them all together?
You can write them all together. Yeah, you can write them all together. So, like, for example, like on number 1, those were both definition of angle bisector. You could put it together. I'm fine with that. I just usually keep it separate, but if you put it together, I'm okay with that. Alright. Where can I go from here? Yeah, okay, I need a side, alright? I've got 2 angles, so that means I need a side, right? EF. Okay, EF is congruent to itself, right? It's the same thing in both triangles. We see that? Okay, so EF is congruent to itself by, what is it? Reflexive, good. reflexive property. Alright. So are these triangles congruent by angle, angle, side, or angle, side, angle, or what? Okay, it's the side in between the angles. Not side, angle, side. Nope.
I had a question.
Okay, go ahead.
Do you need to write out, like EFB equals, is congruent to EFU by,
By definition of perpendicular,
or is that
something like that.
definitely?
I wrote it on mine. So, I would personally say yes, but it could also be implied here. So,
I wrote it out.
I wouldn't count it wrong. No, I wouldn't count it wrong. Yes, Chanel.
So what if you do VF and you can go to UV, so it's like F is like very close.
Okay, we do not know that, but I'm glad you asked that, okay? The reason, we were not told that this is a perpendicular bisector. Okay, it looks like F is in the middle, but because we were not told that EF is a perpendicular bisector, and we were just told it's perpendicular, we cannot say that. Okay? That's a very common mistake, okay? You can't say something unless you're told it, or unless it's an obvious, like, vertical, okay? Does F look like it's in the middle? Yes. Were we told it was, though? No, and that's where the problem is, okay? But very good point, yes. Alright, so now let me ask the question again. Are they congruent by angle, angle, side, or angle, side, angle? Angle, angle, side. Okay, that side is not in between the angles. Okay, if it were angle, side, angle, my side would be here. Just think about how you're reading it. Angle, side, angle. Angle, angle, side. Okay, that side is not in between. So because it's not in between, it's got to be angle, angle, side. Okay, so I can say that EVF is congruent to EUF by angle, angle, side. Alright, once again, anything about that that's not clicking, I need to know. People are being a little too quiet than something else.
How do you know when you're done hosting when you start?
Okay, good question. Alright, did you talk about each piece? Did you talk about the angle? Did you talk about the other angle? Which, in this case, you could have said this, or you could have gone as far as, like, that's what Timothy was asking. He said, can I say that EFV and EFU are congruent to each other because it's perpendicular? And then I've talked about the side. So as soon as you've talked about all three pieces, you're done. Okay, very good question. Any other questions? Once again, speak now or hold your peace. Various.
How, like, this is my question. How do you know what to do after you say you're given? Like, how do you know what to do?
Okay. That's when you start looking for other obvious things. Okay? Which quote unquote obvious. They'll eventually be obvious. Okay? If you need to, redraw the triangles. So if I need to, I have EFB and EFU. Okay? I was told that those are congruent, and I was told that those angles are congruent. Okay? Start looking for other things. Alright? I've got two angles, which means I need a side somewhere. Okay? And then notice that I have EF and EF. Okay? That's the same segment. So it has to be congruent to itself. And from there, I've got everything I need. I've got an angle, and a side. Okay? Because you only need three things. So that from there, you can start saying your final statement. Okay? So list off your givens, and then start looking for things we've talked about. Midpoint, reflexive, all those things. Because what hopefully y'all are noticing is there's a theme, I guess. Things are coming up over and over again. Midpoint, bisector, vertical, reflexive, all that stuff's coming up. So just start looking for, I get it's difficult, okay? I get it. Trust me, this is not easy stuff. But look for things like that, okay? If you need to make like a mental note in your head. Is there a midpoint? Is there
Are there vertical angles? Is there a perpendicular bisector? Okay, all those things are common in this, and they're going to keep coming up. Okay, does that make a little sense? Okay, that's a very good question. Are there any other questions? All right, then let's continue to number 3. All right, number 3. All right, notice, okay, so for 1 and 2, notice, prove the triangles are congruent. Prove the triangles are congruent. For number 3, I'm told prove the sides are congruent. Okay, so if it tells you to prove something that's congruent other than the triangles, that's where you got to use your CP/CTC. Okay, so if it says prove something else and not the triangles, you got to use CP/CTC. But in order to use CP/CTC, you have to prove the triangles are congruent first. Okay, so first let's state our givens. Okay, A is congruent to C. I was given that. Bx is congruent to dx. I was given that. Let's write that down. Alright, so I've got side and I've got an angle. Okay, so think about the things I just mentioned to you. Midpoint, vertical angles, bisectors. Is there any of that you see in this picture?
BXC is vertical to DXA.
Good, good, okay. Intersecting lines, opposite angles. So those are going to be congruent to each other, okay? So BXC is congruent to DXA because they're vertical. Good. Okay, so notice I have an angle, and then I have another angle, and I have a side. So that's what you were asking, Elise. Have you talked about everything? I've talked about an angle, I've talked about a side, and then I've also talked about a second angle. Okay, and that's 3 things. Typically, yes. Typically. Like, you may have several givens that may help you out, but at the end of the day, it should, like, you should have a side, an angle, and a side. Or an angle, a side. Okay? Alright. So, is it angle, side, angle, or angle, angle, side? Angle, angle, side. Good. Okay? The side is not in between the angles. Okay? So I can say that triangle BXC is congruent to triangle DXA by angle, angle, side. But the question asked me to prove that AX was congruent to CX. Okay, so that's where you got to use your CP/CTC. So you can't use your CP/CTC, corresponding parts of congruent triangles are congruent, until you've proved the triangles are congruent. Okay, so now that I've proved the triangles are congruent, look at the picture. Does it look like AX and CX are in corresponding spots? Like same spot in the triangle? Yes. Okay, so because the triangles are congruent, that means all the corresponding parts are congruent. So that means that AX and CX are going to be congruent, because they're corresponding parts, and you would say that is by CP/CTC, and now we're done. Yes? CP/CTC? Yes. And you only do that when the question asks, so notice for 1 and 2, prove the triangles are congruent. 2, prove the triangles are congruent. So you only use CP/CTC when it asks you to prove something that's not the triangles that are congruent. Okay, that's the only time you do CP/CTC. But you have to prove that the triangles are congruent first in order to be able to use that. It's just one extra step. All right. Questions on 3. Take a second look at it. Make sure you understand all of it. If there's anything you're confused about, now's the time to ask. All right. 2 more problems. Y'all stick with me. All right. Number 4. Prove the triangles are congruent. I'm given that AD bisects angle A. Remind me what bisect means?
Cut in half.
Cut in half. So AD is cutting angle A in half, which means those parts of that angle have to be congruent to each other, because they're each a half. So write out your givens. AD bisected angle A. Give. Alright. Start looking for things. What, Mariah? AD is congruent to... No, I just didn't hear you. AD is congruent to... Good, because reflexive. Perfect, okay? AD is congruent to itself. It's the same part of both triangles. Perfect. AD is congruent to itself by reflexive. Perfect. Good.
DAC and DAB would be grouped by the definition of angle bisector.
Perfect. Okay. These angles are congruent to each other. So, what did you say? DAC and DAC. Good. Okay. That's essentially our given. Okay. But those are congruent to each other. Definition of angle bisector.
Would it be DAC and DAB?
Yeah.
There might be less.
There we go. Okay, so we've talked about an angle, and we've talked about a side. What else can I talk about? Y'all think on that. Just Marlon. Hey. Okay. Shut up and post it. Okay. Oh. Mm-hmm. I would probably call anything. Oh, okay, that's fine. Yeah, you're welcome. Bye. Alright, did we think of anything? Go ahead, Julia, what you think? Repeat that.
C and B.
C and B? How do you know that? Okay, let me ask you this. What's this angle right here?
Provided.
A right angle. Okay, tell me why it's a right angle. What would I put as a reason? Supplementary, there we go, supplementary. Okay, this is a line. So it's got to add up to 180, so if this is 90, then that must be 90. Okay, so I can say, let's see. CDA is congruent to BDA because they're supplementary. So now I've got two angles on the side. So these triangles congruent by angle side angle or angle angle side? Angle side angle. The side is in between the angles. Okay. So I could say that triangle ADB is congruent to triangle ADC by what you just said, angle side angle. Okay, take a second and look at that. Make sure you don't have any questions. Bailey, yes.
So like I get just confused about what angle side angle is and all this other. I'm just confused what it is.
That's okay. Okay. This is angle side angle. Side in between. Okay, read it like that. Angle side angle. Okay? Angle angle side. Side not in between the angles. So if it were angle side angle, your side would have to be here. Okay? So angle side angle, the side must be in between. If the side is not in between, but you still have two angles on the side, angle angle side. That helps a little. A little. Okay. It's going to take practice, guys. It's going to take practice. Be patient with yourself.
I have another question.
Okay.
I just like looked down, I was writing my given, I just got so lost. It was like, can you put like little dash things, like control, like when you put little dash things for like flow A, or like A, I was just so confused about like
This?
Yes, I was so confused about it, I just looked down.
Okay. AD bisects angle A. Okay. So this line is bisecting this entire angle. Bisect means cuts in half. So if it's being cut in half, the two halves have to equal the whole, right? So that means that this half has to equal that half. So that's just for the angles. Those arcs are saying that those angles, this angle right here and this angle right here, are congruent to each other. And they have to be congruent to each other because the angle is getting cut in half. Other questions? Trust me, I want y'all to ask questions, okay? We have time.
So you wouldn't say with bisect, so you couldn't bisect it if it wasn't equal on the side, like it wasn't equal.
What do you mean? I'm sorry.
Like if you're just one triangle and it's not equal, cut it in half, you wouldn't bisect.
Correct. Yes. Yes,
I
Bailey.
have another question.
That's okay.
What would it, okay, if it were to be angle side, what would it look like? Like if it were to be?
Bailey is probably asking questions that people are afraid to ask. Okay, I'm totally fine with it. Ha. Let's see. Okay, if it were angle side.
Would it be like B and C?
Yes. Okay, so if I'm still told that this bisects, those are congruent, and then I have that side. Let's say that we were not told that this was 90 degrees. Okay, it's 89. Alright. Those angles would have to be congruent. So angle, and notice that the side is not in between the angles. The side is just there. So that would be an example of angle side. But in order for that to work, I would have to be told, probably in my given, that those are congruent. Because I have no other way of knowing that those are congruent to each other. There's no midpoint, vertical, None of that works here. Mason.
Since I did say it was a right angle, couldn't she just say like that bottom line, that they're congruent since it's in there? Because if it's a right angle and up there is a bisector, then
That's the tricky thing with this problem. We weren't specific. We were told it was an angle bisector. We weren't specifically told it was a perpendicular bisector. Okay, so it is perpendicular, but we don't know 100% sure if it goes to the middle or not. Does it look like it is? Yes. Can we assume it is? No.
if it was getting an angle, like it made the bottom angle different, something like it.
You don't know that for sure. That's the problem. You don't know it for sure. You gotta be told. Okay, you gotta be told.
Yeah, that ain't right.
Do what?
That ain't right, I'll just read it.
Yeah. Other questions on number 4 before we do this last one? Okay, I really appreciate the questions. Yes, Bailey.
Okay.
You're okay. You're okay.
So, how do you exactly know that there is to be another right angle on the other side of things?
Okay, because this is a straight line, right? Straight line adds up to what? 180. If this is 90, what must that be? 90.
So how do you know it's a straight line? Like, how do you... Like, I was like this.
I mean, that's a valid question. I think it would have to be pretty obvious if it wasn't. That's a valid question, though. All right, any other questions before we move on to number 5? You're okay, you're okay. I appreciate it. All right, let's do this last one. Prove that triangle PQR is congruent to triangle PSR. Okay, label as you go. I'm given that PQ is congruent to PS. Okay, given. PR congruent to PS. Given. Oh, thank you. PQ. Alright, also, given PR is perpendicular. That upside down T means perpendicular. PR is perpendicular to QS. Given. Alright, what else can I say?
PR is compared to PR.
Good. Okay. PR. It's the same for both triangles, right? So PR is going to be congruent to itself by reflexive. Okay. PR is congruent to itself.
And PR is congruent to QS.
Repeat that.
PR is congruent to QS.
How do you know that? I got that. Yeah, PR is perpendicular to QS.
PRQ would be congruent to PRS.
Okay. Okay. So PRQ is congruent to PRS. Definition of perpendicular. Alright, so let me ask you this. I've got two sides and an angle, but it's not side angle side because that angle would need to be in between the sides. What's one we talked about at the beginning of the lesson that I haven't brought up? Hypotenuse leg. Okay. Do I have a leg?
Yes.
Are the hypotenuses congruent to each other?
Yes.
Yes. Are these right triangles?
Yes.
Yes. Okay. So I've got my leg. I've got my hypotenuses. These are right triangles. I can say that PQR
is congruent to PSR by hypotenuse split. Okay. Alright, here's what I want you to do. Take this seriously, okay? I really want you to read over your notes for about a minute. Okay? I really want you looking through them, and if there's anything you're not understanding, I need to know. We have time that we can talk about it. Okay? So take about a minute, read through your notes, take it seriously. Don't use it to play on your phone. Okay? Take it seriously, read through it for about a minute. And if you have questions about any certain problem, I need to know now. Like I told you at the beginning of class, I'm going to do what I can to help you, but you also have to take responsible for your learning too. So if there's something you're not understanding, you have to tell me.
Are we doing it on the money?
Maybe. Bailey, yes.
That's so stupid.
You're okay.
So you go back if you go back all the way to number 1, so it's
The proof, or
no, like just like the whole problem.
the very beginning?
So if it was like gonna be like single side angle, would it be like the speed like for the student like?
Uh-huh. Okay, that would be angle side angle, yes. But because it's not there, it's angle side, yes. So I think what we're going to do tomorrow is some practice. That'll be a good idea. Do what? What practice? You can do your homework.
We get parents.
Okay? You can do your homework. And then tomorrow, I think we're just going to do some practice. And then I had another lesson to do, but I think I'm just going to scrap it. And then I think what we'll probably do is review Wednesday, test Thursday. Okay? If I need to, we'll test Friday. But my thought is that some of y'all may not be here Friday. Of course, of course. I mean, y'all know what next week is, right? Yeah, Mardi Gras, okay? So I want y'all to take this test for Mardi Gras, because, let's be honest, we're going to do poorly on it if we wait, right? Yes, Miss Barlow, yes, we're going to do horrible. Yeah, most likely.
Lessons next Thursday and Friday.
Yes, but they'll be very easy.
Like we're test on those lessons for Thursday and Friday.
Eventually,
Eventually, like when's eventually?
before the end of the quarter. You only have 2 more tests this quarter in here. You've got this test, and you've got one after Mardi Gras. That's it.
Is this our last quarter?
Hmm?
Is this the last quarter?
The last what?
Quarter.
Next quarter is.
Oh, quarter.
Yeah, we're in 3rd quarter. Yes, ma'am.
Oh yeah.
Hush, hush. Yes, ma'am.
On the front, number 8, can you do that again? So it's like,
Ma'am.
how do you know conditional equation? How do you know it's like conditional?
Here. Okay. Let me redraw the triangles. Redraw them if you need to, okay, Bailey? Redraw them if you need to. Okay, I'm told that I have that angle and I have this angle. And I want them to be congruent by angle, angle, side. Okay? So that means I need a side and I need another angle. Okay? Notice that each of these triangles does have LK as a side, right? So those are congruent to each other. Now I need an angle, and that angle cannot be in between, or the side cannot be in between those angles. So what's my only option for angles? Like, let me ask you this. If I put my angle right here, is that angle side angle, or is that angle angle side? Yes. Okay, that's not what I want. So, where do I need to put the angle? Yep. That's it. But yes, okay, so when we get back from Mardi Gras,
There will be 2 lessons, but one of them is Pythagorean theorem, which we've already done. And then the other one is very, very easy. It's called triangle inequality theorem. It's just, how do you know a triangle can be a triangle? It's really easy. And so those will be the 2 lessons we do that Thursday and Friday. But honestly, we'll probably do them in one day, and it'll probably take 30 minutes max.
2 months of school now.
There is.
We got 3 days.
May 26th. About 2 months. Or 3 months. 3 months. Alright, let me show you something on your homework real quick. Because I think at a first glance it's really overwhelming, but once you see it, it's actually pretty easy. Alright, so if you go to triangle congruence, let's do a different one. Okay. If these triangles are congruent, tell me which one of the 5 theorems tells me so. Look up here, everyone. Tell me which of the 5 theorems that we've talked about shows that these 2 triangles are congruent. Angle, side, angle. Okay, I have an angle, a side in between, and another angle. Okay, so I would say they are congruent. And then it gives you this flow chart. Okay, and what you're doing is you're proving that. Luckily, all your reasons are given because everything's marked. You're just going in there and marking everything. Okay, so for example, if I want to talk about an angle, okay, everyone look up here because you're going to be confused. Okay, if I want to mark an angle, I need to click on the angle button. So even though it says X and Y, this is still just for your angle. Okay, so which angle in this triangle is congruent to angle A? Uh-oh. Okay, let's talk about a side. Pick that button for sides. Which side is congruent to AC? OM. And which angle is congruent to angle C? M. So I can say these triangles are congruent by angle, side, angle, or side, angle, side. Okay, look, Bailey, what do you have? You have 2 angles and a side, right? So if you have 2 angles and a side, it can't be side, angle, side. Okay, because if it were side, angle, side, you would have 2 sides and 1 angle. Okay, so this is angle, just read it, look, angle, side, angle. Okay, so I would say angle, side, angle, submit, check.
Instead of them, like, so they just put like the lines on the angles, so some lights are just like 2 instead of just doing 2 like of the circle.
Yes, correct. Alright, any final questions before you start your homework? I think we're going to stay in here, because I want y'all to focus. Okay, work for about 10 minutes. If you have questions, please ask. And then our plan tomorrow, we'll practice. I have an activity we'll do. It's like a cut and paste activity we'll do as practice. And then Wednesday we'll review, and hopefully Thursday we'll test. Okay?